So here, this is what will be on the formula sheet and what you'll be used to. So again, make that laundry list. And if you look at this first one, I will type it for you. This first probability is for the keyword. So I'm going to arrow this. And look, I can do this little nifty thing. Oh, never mind. This is for the keyword or. The or is your addition rule. Okay? So when you see the word or, what's the probability of pulling a boy's name out or a girl's name out? What's the probability of rolling a 2 on a dice and flipping heads on a coin, or flipping heads on a coin? Okay? When you see the word or, that's the addition rule. Okay, so the addition rule is just taking, you can see here, so look at my cursor. You take that probability of A. So if I'm saying I have all of your names in a hat, right? And what's the probability of pulling a girl, a junior or a senior? Okay, because we do have juniors in here. So what's the probability of pulling a junior out or a senior out? So the junior would be the probability of the A. So I'd figure out the probability of a junior plus then the probability of a senior. Okay? Now, if it can happen at the same time, which means it's not mutually exclusive. So this is your laundry list item here. If you are taking notes on the side because you're using these to study from. Not mutually exclusive. What does mutually exclusive mean? Can't happen at the same time. I exclusively date. I can't date anyone else at the same time. Okay? Then you are not exclusive. So, right? So, mutually exclusive. Let's stay focused here because I'm taping as well. So, mutually exclusive means they can't happen at the same time. If they can't happen at the same time, we don't need to worry about this subtraction piece. Okay, and I'm trying to get an underline here. So make a note to yourself. If they're not mutually exclusive, I don't worry about that subtraction piece. Why? Because they can't happen at the same time. So if you think about it as a Venn diagram, you can own an iPhone and an iPad at the same time, right? Would you agree? Okay. So, oh, I love when my board doesn't work.
So you only do the subtraction if they're mutually
If they are not mutually exclusive. For example, I can own an iPad. Oh, the red light is on. Let's plug it back in. And now it's going to work. Let's see. And it's green. I think we're back in business. Okay, so I can own an iPad. Let's just play pretend. What do you think the probability of someone owning an iPad in high school is? High? Should we say
32%.
Let's say 32%. I like it. Okay. 0.32. What's the probability someone owns an iPhone in high school?
95.
95%?
Actually, no, 81.
90.
81.
I like 81. I was going with it, Eric. Okay. Now, what's the probability that they maybe own both? Let's say 10%?
No, 0.075.
Oh, no. That's too much there. Let's say 0.10. Hey, ladies and gentlemen, these are not mutually exclusive. So the reason we have to subtract, because if I add iPad plus iPhone, okay, I add iPad plus iPhone, I'm double counting. What does that mean that I'm double counting? That Venn diagram, that bone right here, okay? This whole thing right here can be the iPad. So what goes here, ladies and gentlemen? What do I need to do? I need to subtract. So that's going to be 0.22. Right? Because that's the iPad. Okay, again, guys up here listening, please, thank you. And then here's the iPhone. This whole circle needs to equal everyone who owns the iPhone. Well, I already have 10% there, so that's going to be 0.71. So if I added up everyone who had an iPad, that's the red circle, plus everyone who had an iPhone, that's the green circle. I just double counted the both, and that's where this subtraction comes from.
Over 100%.
No, not over, well now if you add it up, is it over 100% now?
Yeah.
You know why it's over 100%? Because we just came up with those numbers. So, but
In reality,
in reality, that won't happen. Again, the reason that happened is because I was just asking you to shout out numbers. What do you think the probabilities are? Okay. And I wanted to show you the reason. So the goal of this question was to show you the reason why we do subtract out if it happens both. Is everyone clear there?
Yeah.
Yes. Okay. Now, the next one is the formula for conditional probability. Well, remember I'm taping, so. Conditional probability. Ladies and gentlemen, again, I'm getting a little too much talking right now, and I'm trying to kind of keep us focused since I'm taping. So, the probability of A given B is equal to the probability of both over the probability of B, okay? The probability of both over the and I always think of this as like my fraction bar, right? Yeah, so if I was doing it with the iPad and the iPhone and the both, here's the thing is, I know those probabilities don't work out, but I want to show you how to use the formula. We're going to just stick with those probabilities. If I say, hey, we know that someone owns an iPad, okay? I know that someone owns an iPad. That's the given. So I would say the probability that they own an iPad. Or that's the given. What's the probability they own an iPhone as well? Okay? How do I do that? Just think of it as, hey, this is my denominator. So that iPad goes in the denominator. The probability that someone owns an iPad is 0.32. The iPad goes in my denominator. Then the numerator is both of them together. So 0.10. They will either give you it, okay, so they will give it to you as both. Or if they are independent, you can find both by multiplying, okay? So the probability of A times the probability of B will give you the probability of A and B. Okay? If they're independent there. Yeah. All right. Let's move on to the actual problems now. If you notice here on the formula sheet, there's the expected value, which I'll address, and there's also the binomial distribution, which I'll address in the problems. Okay, so number 3. This one's kind of a trick question. You have seen this problem before. A pair of die is rolled 3 times. The first 2 rolls resulted in 2 5s. What is the probability of not rolling a 5 on the next roll? Yeah, those are independent. It doesn't matter. Okay, right? Ladies and gentlemen, let me be clear. The correct answer is B. Why is it B? They're independent. It doesn't matter what the first 2 rolls were. All I care about is the next roll, and the probability it's not a 5 will be 5 out of 6. Okay, next. Okay. So B is the correct answer. Okay. This one you don't remember. This one is really an important one. You will see it. Okay, star this one.
Number 4.
Yeah. All right, in a game, a spinner with 5 equal spaces is labeled A through E. If a player spins A, they win 15 points. If any other letter is spun, the player loses 4 points. What is the expected gain or loss playing 40 games? What is the key word that I would probably circle if I'm taking the test?
Expected.
Yeah, that's the big one, the expected. Okay, you're not wrong if you circled other things, but that's what the question is getting at. expected. If you go to your formula sheet, or you go to right here in the packet, your expected value is right here. So this is the expected value of a probability distribution. Well, I don't have a probability distribution, but I have to find the probability distribution. So I talked about this in the review session yesterday. You will either be given a probability distribution or you will have to find a probability distribution. So moving to the problem. Sorry. I'm not given a probability distribution, but I want to know the expected gain or loss from playing 40 games. That's important. Well, I can either win 15 points or I can lose 4 points. So this is my win or loss right here. And now I need to know the probability of a win or loss. Well, I get 15 points if I spin the letter A. There's 5 total letters, so what's the probability of spinning an A? Yeah, 1/5. Which leaves the probability of losing would be any other number, 4/5. To review what a legitimate probability distribution is, in case it is asked on the test, something to the extent of, is this a legitimate probability distribution? There are 2 things you need to state. So this is a side note laundry list idea. You need to state that each individual probability is less than 1 or between 0 and 1, because you can't have negative. So the probability of each event is between 0 and 1. And the sum of the sample space, when you check those probabilities, they are equal to 1. So that's a side note, little laundry list review piece. That has nothing to do with the question right now, but I think it's important to know when you're dealing with a probability distribution. This problem is dealing with a probability distribution, and another thing you can do with a probability distribution is find the expected value. Now you have to be able to show your work to find this expected value, but you can use your calculator.
You would have to show your work as multiple choice.
You're right. On this one, you don't have to show your work, but I want to discuss, since we're just reviewing for the exam, how to show your work. Okay? Looking at the formula sheet, XI, write this down if you need it. That stands for the observation. So your first observation, you could say. The probability of XI then is the probability of that observation. XI is the observation. P of XI is the probability of that same observation. You need to add it all up. Now, on a free response question, you don't have to show every single observation if there's a lot. You can do a dot, 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 which means continue on. Okay, how do I show my work here if it was a free response question? My first observation is 15. Observation times the probability of that observation times 1/5 plus the probability of the next observation, -4 times 4/5. Okay, you can type that in your calculator. In fact, I would argue that just typing that in your calculator will be faster than putting it in list 1 and list 2. Did anyone get the expected loss there? Why is it E? Yeah, so that's what I wanted to get at. Your first, you're going to get negative, is it 0.8, I think? Right? 0.2. Oh, 0.2, okay. And I'm guessing, this comes from an exam booklet, I'm guessing that they might have negative 0.02 as an answer. So the key thing here is, in the question, always reread the question. What did the question actually ask? From playing 40 games, so we multiply that by 40, and we get a loss of 8 points. Questions? They're not going to check your work on multiple choice, so I'll have to look. I'll have to look at what you did. Okay, so just let me know after class. All right, let's move on. Number 6, is that our next one that we had on there? Yes, okay, number 6. I saw a lot of people drawing 2 curves. That's awesome. But what will happen here is when you see, though, now the difference in their heights, automatically you need to think, I'm combining 2 distributions. I'm combining 2 random variables. I'm combining the boys and the girls, which means you would only have 1 curve. Okay? And if they asked about the mean, what would you do with the means? Well, you would just subtract the boy minus the girl, because it says male and female students. What's the difference? I'm going to take the boy minus the girl, so I'm going to take 68 minus 66. This question doesn't ask for the difference there. The question only asks for the standard deviation. And as long as they're independent, when you're combining a curve, the standard deviation is the variance, the standard deviation squared plus the standard deviation squared, as long as you keep going until you get all of your variables. I'm only doing 2 variables here, but there are times where there might be a question about the distribution of apples and you have 10 apples. So you keep going for 10 times, okay? There's videos on that I posted, so please watch that if you're concerned or you don't know what I'm talking about right now. Right now I'm talking about the boys and the girls, so I take their standard deviation squared. Well, what you need to know there is standard deviation squared is the variance. So they already did it for you. So you take 1.52 plus 1.64, and you take the square root of that, and what do you get for an answer? My key, what is it? D. And number 6, I have D as well. Very good. Okay, question.
Variance is standard deviation square root.
Be-
So I can take the standard deviation and the square root of each of the variances.
That's a proof that I don't want to get into right now, just for time's sake. The variance is a standard. That's like a legitimate little proof as why it is. I just don't want to get into that right now. I'll gladly talk about it with you after class. Okay, but just what'd you say, Danny? Okay. Just always remember when you're combining variables, standard deviation squared, and it's always addition. No matter if you're subtracting the means or adding them. All right. Good? Okay. In a litter of 8 puppies, 5 are female, 2 of the puppies are picked at random. Which of the following is true? What is the answer there?
C.
The answer is C. Very good. Do I need to talk about it? Okay. Number 9. Number 9 is a difficult one. Yes. Question? Why is it C? Okay, because you have 8 puppies. But that's what you will do, though, right?
So I didn't know what it was trying to say.
What did you pick?
I picked
B?
Yeah.
I guess I would just assume when you're like, I don't know. I would assume that you're gonna pick one and then the other.
So in that,
And even if you pick 2 at the same time, it can't be 5a squared, right?
Yeah.
the same, like,
Okay.
Yeah. Yes, question.
will they tell you, like, how placement?
Yeah, I think they will tell you without replacement on there. I do. Okay. All right, ladies and gentlemen. Homes built in the suburbs typically have none to 3 car garages. That's important in this question. In fact, I made a mistake because I didn't read that when I first did it. I went to the studio and my answer is not here. Okay. Let X be the number of garage stalls per home and found in a sample of 200 homes in a local suburban area. From the data obtained, this is what they got. The probability that X is equal to 0. All 1 and x is equal to 2. What do you notice? What's missing? There's no 3, and that's what I did wrong. I went so fast because I was just trying to get the answer, and I saw what's the mean number, and I saw that it's a probability distribution. So what I did is I said, hey, I want the mean. I notice I have a probability distribution, and I went ahead and found the expected value. Because the expected value of a probability distribution is the same as a mean. And now my issue is here though, this is not a legitimate probability distribution right now. If I added these up, I don't get 1. The sample space goes to 3. So I need to figure out the probability that x is equal to 3. So how am I going to do that? Yeah, I need to subtract, I need to add the 0.06, 0.45, and 0.32 up and subtract from 1, and that's going to give me 0.17. Okay? Now, I want you to practice in your calculator how to get the expected value. L1 is equal to your observations. L2 is equal to your probabilities. In your calculator, you're going to do a 1 var stats. If you have the old calculator, it's an L1, comma L2. If you have the new calculator, the X list, I believe it says, is L1, and then the frequency is L2, okay? So take a second to do that now, please. What I did over here in blue is I just showed you how you could show your work without having to write all of them down. The blue is a legitimate way to show your work. Did you guys get with a D? Okay, please make a note on number 9 if you have calculator issues, and after class I can help you with that. Okay? Are we ready to move on? Number 10. Number 10, the probability that a randomly chosen American president is Republican is 0.35. What is the probability that in a sample of 10 Americans, at least 1 will be Republican? Okay? At least 1 will be Republican. So what I do here is whenever I see the word at least, you can do 1 minus the complement. The complement is everything else that could happen. At least 1 would be, okay guys, if you have calculators, they'll definitely help you after class. With the Republican president, at least 1 would be 1 Republican president, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Those are all at least 1 out of a total of 10. What's the complement of at least 1? At least 1. X is equal to 1. I could out of 10, right? 2 out of 10, 3 out of 10, all the way to 10 out of 10 could be Republican. That's what I'm trying to figure out. When you see the word at least, you can do 1 minus the complement. What's the only value left over that could happen? 0. This is the complement. So I'm going to do 1 minus the probability of 10 Democrat presidents. Because that's 0 Republicans. Okay, so I'm going to take that 1 minus 0.65 to the 10th power. Why to the 10th power? No, because it's a Republican. I don't want a Republican. So it's 1 minus none. And that's going to give me 8.
You just kind of guessed that too. I just
think like
Could it be at least? Like,
Sure, you can guess. My concern is though on the test there might be like a 0.95. Then what? You know? So, yeah, I mean, multiple choice, they're not checking your work. Tomorrow I'm going to go through these free responses, and then we'll have some work time. All right?